So ladies and gentlemen, can everybody hear me? Yeah. Okay. So I will give you an overview about robotics and industrial AI at Aachen University. But of course I also could give a deep dive into technology, simulation, material science is also my favorite, and tribology. But here it goes more about the industrial application. I think, do I need it? Yes. It goes about the industrial application, about robotics and industrial AI. And of course the question is, how can we really efficient implement these new technology in industry? And you can guess it from the title, it cannot be done the conventional way, you have to use open innovation. It will be, so when I was asked to give a presentation here, I was of course not ready in time, so I took ChatGPT to ask please make me a presentation about transformation and so on. And of course everybody of the younger generation especially knows that ChatGPT failed. ChatGPT said, I'm a text-based AI model, and so I cannot make you a PowerPoint presentation. Of course, there are already tools available, but still, this shows very clearly that AI is not a tool for everything, but for a specific application. So anyway, I had to do it by myself, and I hope I give you an interesting survey about our research in production technology, especially in robot-based. So where are we now? 2023. I was in industry before I came to university, and actually I would say I would not love to be in industry anymore because it's so challenging. You have a total transformation towards high-value production, low cost in competition with low-cost countries. You have a lot of competitors coming up, a lot of technologies coming up. So even in your core business, you have to do a lot of innovation. Different market players. And then of course, also everybody is shouting for sustainability, defossilation, green energy, green mobility, recycling, and so on. And last but not least, the topic of today, I could also talk about the other two, but I will concentrate on digitalization and automation. Everything becomes more digital. Of course, I'm here in Korea and I don't have to tell you, but I think these are three very major transformations. And the sad news, they all come together. And the only solution is how to overcome those three big transformations in one time, in one decade, is just by collaboration. I think nobody, neither the university nor even a market leader, can do it by himself. So cooperation is the key. And I will concentrate, of course, on digital transformation, mainly on AI and robotics. Digitalization, in many cases, even also in Korea, is very much attached with the term in Germany, Industry 4.0, Industrie 4.0. In Korea, of course, with the Smart Factory initiative. But this is only one of four categories. There is also, every product becomes more digital. Even a bottle, a towel, clothing, everyday products, a car has a coffee machine. My toothbrush is connected with the internet. And so everything becomes digital. Also textiles, we are working on wearable textiles, not the topic of today. Digital production, beside the conventional high volume throughput production, now digital production comes up. Digital printing, 3D printing, and others. And of course also the work life changes very much. We call it in Germany Arbeit 4.0, work 4.0 is of course also a big trend. When we talk about how will the future work look like, work 4.0. Then when I was making the presentation actually for a large international conference, when I was preparing it, there was this study upcoming, you can read it in the internet. There was a comparison between doctors and artificial intelligence, ChatGPT. And of course, if you know some doctors, with the first question you're quite clear. So the empathy, ChatGPT is always very soft and very polite. Doctors sometimes are not. But what is even more worse is that the quality of the responses, see this, it's 4 times bigger, 4 times better, 4 times. And then of course, being more polite and being better, the recommendation of the patient was much more in favor for ChatGPT. And you can of course say, well, this is a big threat for everybody, even for us academics. Well, and this is the question, is it still an opportunity or is it a big threat? The thing is, in most of the mature economies, and I really admire the Korean Wirtschaftswunder, you have done it in 50 years on a high level of each industry nation with the utmost speed. But all mature societies now, the birth rate goes down, which leads sooner or later to a lack, a demographic development which nobody can stop. So in Central Europe, it's 2 baby boomers are facing retirement, like me, in 7 years, and there's only 1 job starter. And this even becomes more challenging than because in hard STEM subjects like mechanical engineering, electric engineering, physics, mathematics, the number of fresh students declines, although they are needed. Many of them, there is not that they don't like technology, but most of them go into biotech or informatics or ICT, but not in what we have seen before, engine engineering or textile machinery. And so, actually, automation or robotics is not only, as it has been discussed before, for the blue-collar workers in the factory, it's also for the white-collar workers. So we have to think about automation in every aspect of work life. And then, of course, we have to think where is, for example, AI more efficient and where is an ingenious engineer still needed. And I pretty believe we have a lot of things to do from our technical side. One thing is, when I said if you consider to introduce advanced robotics, if you want to use AI in production, the classical approach would be you have work packages from upper left to lower right. You develop technologies from fundamental research, making patents, collaborative research, development project, engineering services. Yes, you can do, but my strongest belief is don't do it. Because this is inefficient, it is ineffective, and it does not include different kind of disciplines. Because AI, you have to integrate people from ICT, people from production technology, people from social sciences, and so on and so on. And you have to do it different. I'm pretty much convinced. I will give you also some examples where we did it in a different way. So, for the solution for complex transformation is collaboration and open innovation in AI. Okay. First of all, I want to give you a short survey and also invite you maybe to join Aachen University if you're a student for a PhD, for an internship. I saw that you have an internship center. There are a lot of companies around the campus, so a lot of opportunities. One opportunity to come to Aachen is an international master course on robotics. It's also interdisciplinary, a 2-year course program, by the way. Then I will give you some examples where you can find robotics not only in teaching but in research. So in research, in every faculty, even in those faculties which have non-engineering names, you can find topics like AI, which are technically oriented. First of all, in the faculty 1 there is the informatics, the ICT studies. There is a large Fraunhofer attached to our university, and they have one of the directors, Matthias Jake comes sometimes with me to Korea, and he's a co-creator. He was in this expert group which invented the name Industry 4.0 12 years ago. And they have, of course, an alliance among the other Fraunhofer institutes in Aachen. There are also a Fraunhofer Institute for Laser Technology and one for Production Technology. Some of you know it. And they have cognitive robotics and AI. Then in the Faculty of Architecture, there is one professor, Mrs. Troy-Kopchan. She does uses robots for individualized building products. This will now, of course, a kind of spotlight, flashlight running through the faculties. In the Faculty 3, this is the Faculty of Civil Engineering. Professor Clem Albert, she has an open lab. This is the first indication of open innovation. A learning factory, how to use robotics in making a building, so for craftsmen and on site especially. A little bit also in building factories for building materials, but mainly concentrating on site. Because also craftsmen are lacking. So the percentage in Germany going to university has dramatically increased. So the number of young people going into craftsman education has declined. So there's a big lack. I read just 10 minutes ago in the newspaper that the Craftsmen Association warned that there are not enough skilled people on site. There are enough engineers, but not ordinary workers on the construction site. Then, of course, this is my faculty, Mechanical Engineering is the largest one. We have in our faculty almost as much student as Ulsan University. It's a core of the Aachen University, and there are different disciplines: production technology, textile technology, polymer processing, automotive engineering, chemical engineering, and in each of these different groups you can find application of robotics for production, for joining, for assembling, and also for testing and others. Then also we have, Aachen was founded more than 150 years ago. We have a strong faculty in mining. Mining and mechanical engineers were the reason to found the university. And this is Professor Clausen, and she works on autonomous machinery for mining. Not only coal mining, but every kind of mining. Navigation, and so on. There's a large project called Mine Revier, which is playing with words, of course, and dedicated especially to digitalization in mining. But this is not enough. There's another faculty for electrical engineering. Of course, they also do automation, and especially Professor Rossmann does automation, which does not necessarily lead to a typical robot. So he, for example, works on automation in space, in automation in agriculture. So, for example, this is an autonomous tractor for agriculture, which is navigated by GPS, knows exactly the weather, the status of the crop, and so on. Now we're leaving, let's say, the natural science and engineering faculties, going to the faculty of our business school, and especially in Aachen we had 15 years ago the so-called Excellence Initiative, where the top universities were ranked, and Aachen was the first technical university in that field, and of course it's also leading by other indicators. And anyway, but we used the transformation of which we could make through the Excellence Initiative also to strengthen the non-engineering science, especially the business school. There is now a center called Time, which is very much strong in digitalization, in digital business models. Frank Piller, for example, is for that, and also Malte Brettel is the anchor person for our incubator, which Aachen has the highest number of deep tech spin-offs in Germany. And then, of course, social sciences. I was always convinced that not only for the acceptance, but also for the creation, for the understanding of the user needs, we need the social science. And again, we used the funding from the Excellence Initiative to set up one of the largest centers worldwide called Univ, which is humanities. The professors are still social scientists, philosophers of different disciplines, but in order to support us in our technical development. And in the most of our large projects, for example, at my institute, I belong to the Faculty of Mechanical Engineering, I have one colleagues with them, and they always pay a great contribution to make, to increase the quality of our research. So there are different ones. This is how they work. They also are very good in empirical science, so they really can evaluate whether a technology is better, because me as an inventor, I always will say my technology is good, isn't it? But they do really qualification, is it better or not, what can be improved, and like that. A very good center. And last but not least, we have also University Hospital. Robotics in the medical field can be divided in 4 applications, and again here there is a big lack of working people in a hospital, but also in the hard part of the hospital, mainly in the surgery, operation room, theater. But if you take a closer look into robotics in medical field, there are, of course, the robots who do, for example, something in the surgery. But also there are robots for services around the medical care, robots for the rehabilitation, which is a big topic. We have also, my institute has a strong collaboration with Hexar from Korea, a professor from Hanyang University who develops exoskeleton in one application is rehabilitation. He's very much leading, but he does not have an office yet in Europe, and we are going to open this with him. And last but not least, there's also robotics for care of elder people, so long-term care. We have, so these were different activities. Now I just show some large-scale projects. So we have, through the Excellence Initiative, we have, due to the fact that we are leading in production technology, we have the so-called Excellence Cluster Internet of Production, and more than 25 professors and more than 150 researchers are working in this research area now in 10 years. And are interconnected and interdisciplinary during their PhD. So how do we, open innovation. So where is open innovation? I will give some examples. First of all, we bundle our activities. As you have seen, it's spread over the entire university. So therefore, just 2 years ago, and we founded the AI Center at Aachen University to build up the methodology competence, to integrate the different disciplines and applications, to learn from each other, and of course to strengthen ourselves in order to get more money, either public funded or industry funded. And just 2 weeks ago there was the AI Day, and we had a big week in Aachen together with the city, also integrating the ordinary people of our city. And this is really a success story. More than 95 full professors, so we have a different counting, it must be said. You have more the American kind of counting. So when we say professor, we only mean full professors. So 95 faculties from 85 institutes of the entire universities are members, are working together. And of course pushing the methods, but also to learn from the application what can be done, plus, as I mentioned, the Univ considering the ethical, legal, and social and economical aspects. So this is of course the AI landscape. The PDF writer destroyed a little bit of the order in this table, and I don't want to go into detail, but it's quite comprehensive. Now I want to give you a first example how we use open innovation from the beginning. So I was in my industry career also at McKinsey, and when the term Industry 4.0 came up, we had several flagship projects at our institute, but I was not really convinced. I think we have to do something different, we have to build capabilities, we have to innovate, we have to integrate other people. And once driving in a train, the Thales, which is quite similar to the KTX, I met the former CEO of McKinsey Europe, and he said, "What are you doing?" I said, "Well, I'm doing Industry 4.0, but I would like to speed it up." And he said, "Have you thought about a model factory, a learning factory? Shall we do it together?" And this was the starting point. 2016, we opened the first model factory Industry 4.0 worldwide in cooperation with McKinsey, and it's a learning factory. So it is a process which shows different kind of processes like assembly and thermosetting. Here's the assembly line. Then we have here cobots, predictive maintenance. We have here a fully automated warehouse. So very typical processes which you also find in industry. And the basic difference is there is one partner from science, us, one partner from consultancy, McKinsey, which gives the money for the investment and also for the ramp up. And then there's a partnership model. So we have now almost 20 partners from different sectors, Microsoft, for example, and others which you probably don't know, smaller and larger, and they provide three things. One thing is the membership fee, which is of course important for running the factory, but then they also have to commit to bring in latest technology. They have to bring in a certain manpower or personal power, and then of course on the other side they get into contact, they can show a full picture, because every of those technology partners has only one component. None of them has the full scope of the factory, and so they can show their core technology in a full semi-industrial environment. And on the other hand, we have here high-level customers. We come here to see the latest technology, to educate their people, and then of course to working on concepts, how they can implement these solutions in their company. This is a picture, how it looks like. By the way, here, leaving the topic, here in this part, there is a joint lab, the Smart Techtronix Center, which we run together with Kitec in Ansan, on wearables. But the main part here is the model factory Industry 4.0. So the benefit for the technology partners is, of course, over the last 7 years we had over 7,000 visitors. We had a lot of workshops with customers, and this is of course good for the partners, good for the customers, and all of us. A similar open innovation platform, our colleagues from FIR, the Institute for Automation, made on the topic of building sector. And this was really interesting. When I first heard, I thought, how can they do it? A model factory using smaller machines, I can think of, but a model house using smaller house, so what is it? No, they of course cannot show full-scale skyscrapers, but they have a building emulation. They show, for example, smart switches, smart air condition, completely digital building monitoring, and so on, in certain showcases. And for example, one part of their business model is that today there are a lot of suppliers providing single solutions, for example, for switches, for air conditioning, for safety systems, and others, and they have to interconnect. So what they do, they can, with the emulation of the building, they can evaluate the interconnectivity of components. And this is, of course, good for the component provider, so he can say it's proved by the Smart Commercial Center, and it's good for the contractor which builds such a large building, because then he can choose components where he can rely on. So these were two examples for open innovation labs. Then, of course, the method, agile product development. Many people only talk about the sprint phase, which is possible to create prototypes, but of course you shall never neglect there's also a search phase before. And when I first heard about it, I was a little bit reluctant, because I was also trained and teach by network technology, project management, whatever MS project. I was spoiled, but when we erected the microfactory for Industry 4.0, we used this method. So we brought in all partners in one room, and not contracting and a project manager, and then we have a claim manager, and then we exchanged PowerPoint. No PowerPoint. There was almost no reporting to me, which I also had to learn. I would only step in once a month and say, are we still in time? And they say, yes, we are in time, and then I left the room. And the team, not only my team, the team of all partners together was responsible to make it in 3 months. We really erected a factory in 3 months. Before I was in an engineering company, when we erected, for example, a polyester plant here for SK Chemicals, it took us 2 years or something like that, or 3, if there are some claims around. And so this is a good example that it really works. I had to learn it. Then, of course, if you do so, you have also to provide, don't have to change the method, you also have to provide rooms. So this is, for example, a creative lodge, which is a little bit like a farmhouse, but in order to bring people out of the office boxes into a different environment. Inside it's very fancy, design-oriented, and then to get new ideas. Then we have 2 places in our institute, a creative lab, where we do all the prototyping, 3D printing, 4D printing, also the smart textronics, where we use electronics to integrate textiles. This is for, let's say, agile product development. And then in our main institute, we have a creative fab, which we use for agile machinery development. So, for example, in our main show, which is the ITMA for textile machinery, 4 years ago we won the Innovation Award with a machine for braiding ceramics, for example, for high temperature combustion and ceramic matrix composites. This was the machine, and the machine is very interesting. It was an old machine which we refurbished and fully equipped with sensors and individual servo motors. So bringing an old machine into the Industry 4.0 age, and this was get them the award of the exhibition. But the main thing is it was in a special area which was only dedicated in the team of different disciplines, and sometimes also the sub-suppliers were working together. Also for the demonstration, we need such close to in the same building like the model factory. We have the so-called docs in cloud, and they have a living lab which looks like a hospital room. And this is Professor Chapik from the medical technology, and he showcased here, let's say, medicine 4.0. So smart medicine, he does also remote consultancy and these kind of things. And very important for the acceptance of his products is that he demonstrates it in a room which looks like a hospital. And the next step, of course, we are planning is, if we do so, there is a last mile missing. So this is an outlook into the future. It's not existing. You probably have heard Germany has stepped out of fossil energy, coal mining, within 15 years, so 2035. We have stepped out of coal-based, of nuclear-based energy 10 years before. And then, of course, the question is how to transform the industry. There is a lot of transformation funding from the federal government. And one project which we have won so far is to create the textile technology park. You would call it in Korea conversion center, industry park close between Aachen and Düsseldorf. And this is an area of 20 hectares, 0.2 square kilometers. It shall be equipped with renewable energy supply, not only electricity but also heat, what you need in an industry park. It shall be equipped with the latest digital technology, and then of course it shall invite people to work together, for example, digital company with textile company, automotive company with textile company, and whatever. And the main building which we are designing is the so-called factory, where we have again open innovation spaces for the creation of smart textiles, of bio-based textiles, micro-factories, because if you bring back production into high-wage countries, the production will look different. When we do the education, and this is, fills roughly 10% of the central building. The other 90% are incubators for startups or companies which want to collaborate. And then, of course, the rest of the industrial area is free for people, but they have to be innovative and they have to cooperate and do new things. So this is a vision. We are now at the stage that we have to supply the final proposal documents, and we hope that we can open these areas in 2 years, I would say. But it must be said, when we first showed the idea 2 years ago, there were of course companies knocking at the door and say, hey, this is a good idea, can we do it? And of course, you know, if you want to develop an industrial park, it takes some time. The good thing is we had already a real estate existing, a technology center, an incubation center close to that place. So for example, the company C&A, which is a large textile retailer, already produces chinos, almost like that, in a high-wage country, which are formerly only produced in Bangladesh, Romania, or so on. So shall be a place where we bring back technology close to the rural area, which is with 20 million people, one of the most highly populated areas in Europe. So it's a model case to also show whether the ideas which we have are really working. But I'm pretty much convinced that through collaboration we can do it. Thank you very much.
Thank you, your invaluable lecture. 위협을 캔디 받겠습니다. 질문 있으면 잠깐 끊어서 회시해 주시기 바라겠습니다.
Thank you for your presentation. I have a question. Thank you. Thank you for your very good presentation. I understand that robotic application into textile manufacturing because textile is very flexible and no physical shape, so really difficult to apply robotic application successfully. So you introduced some of the robot application to textile manufacturing. So can you introduce any facility successfully apply to the textile manufacturing?
It's an interesting question. Yes, I'm coming from the Institute for Textile Technology, but I think there was no example for textile automation. But anyway, you're right. Textile, we have especially for that purpose, we're doing some research, but we have especially one in my institute group, which comprises of 500 employees. We have one different institute dedicated to advanced robotics, because what you said is right. There are a lot of course, robotics today are used for welding, for joining, especially for rigid parts. Easy. Then you train them very long. I was with Ford Motor Company. I spent my life as a young engineer. And all of us know how long it takes to train a robot. Some weeks. But then they produce it everything the same. So I always say traditional robots, the most of the robot applications, let's say 95% of industrial and plus of the industrial today applications, the robots are just slaves. You once train them the curve, and then they do it. Day out, day night, day out, day now, they never get tired. They don't went on strike. This is advantage, but they do only the same. And now you say, of course, for textiles, this does not work. Textiles are not form-dimensional, but this also counts for other examples. For example, the first project we had with this company was very thin metal sheets, also are not very stable. And rubber materials, films, all of them are not really stable in shape and memory. Then the traditional strategy to let them follow does not work. And this is actually the starting point for advanced robotics, where you have to film, for example, where you have to interact with your product. And the funny thing is, in this group, we not only have industrial robots, we have also the medical robots, because at the end of the day, a patient, if he's ill, is also not form stable. And so the same kind of automation you need. Also, when you do collaborative robotics, then it does not make sense that the one part, the robot, is a slave and the other one is not a slave. Then there is no collaboration. So all these modern things of robotics needs a totally different control philosophy, sensor integration, interaction with the product itself or the co-worker. And so this is why when we talk about advanced robotics, smart robotics, there are a lot of words around. We have to change the entire philosophy of robotics, which we have learned over the last 50 years. And this is not only valid for textiles especially for textile assembly, but it's also valid for many, many other applications. And the main innovation is especially in this field. And it's not solved. So yeah, I would not dare that we have the holy grail of soft robotics. We don't. So for example, next week I will meet some colleagues from SMU. They have soft robotics labs, because there are also very interesting ideas around here in Korea, especially especially in East Asia, because there is a different approach in designing the systems. Therefore, I like to come to Korea 2, 3, or 4 weeks, typically per year, to get inspired. And again, to take these very good ideas in East Asia and bring it and implement it into industry needs, again, some collaboration, even between cultures.
Any other question? Okay, I have one question. Do you think there any opportunity to have a cooperation between the IM University and the Ulsan University, or any other Ulsan companies, maybe doing some collaboration project or exchanging student program, something like that?
There is always a chance to exchange students. Yes. This is the most easiest one. Of course, we can exchange students within the curriculum, one possibility, but I would say some of our curriculum is still in German, so this needs some German languages. Therefore, I would recommend even more to use the chance for doing training and internships. And then of course you get even more view into how is daily life. Then in lecture halls are all the same all over the world, but really working with the people is where you get an insight into the culture. With industry there are different ones. We have of course research with Korean companies, especially my colleagues from production technology and also metallurgy, material science, work with POSCO and others, pretty strong. But there is also a good opportunity for small and medium-sized companies, because since almost 10 years there's a large support as well from MOZI, as well from MSS. There are support actions through KIAT, and then there's large support by KOTRA to enter new markets, and we use these measures to provide services. For example, we developed with a company providing adhesives for shipbuilding, a company Unitech. They were in shipbuilding and automotive, very typical, and we helped them to enter a new market, means carbon fiber composites. This is one example. But so we help people to enter new markets or new technologies, and this is very much supported, as I said, by MOZI, MSS, and then of course operational support.
Thank you for your answering. So I think let us build this relationship. Yeah, for the future. Thank you.
That's why I'm here.
잠깐 소개를 하면요. Okay, I will introduce your institute and your activity, and so on. So why you come here? So for collaboration with us and so on. 실상 이분이 여기 지금 한국의 아까 아켄 공대의 부총장인 겸 지금 또 맡고 있는 보직은 노드라인 베스트팔렌 주 정부에 그다음에 한국에 집출한다든지 이 사람은 국제 공동연구라든지 이런 데에 이제 관심이 있어가지고, 예를 들면은 독일의 벤처 스타트업 컴퍼니가 나왔다. 그러면 그 갖고 있는 기술이 있을 거 아니에요. 그럼 그 기술을 갖다가 우리 울산에 있는 한국에 소개를 해가지고 같이 이렇게 해서 기술 이전을 받든지 코퍼레이션을 하기 위한 그러한 주정부의 역할도 하고요. 그 다음에는 또 우리 대학 교수님들이 하게 있으면 아켄공대에 어떤 교수하고 국제 공동연구를 하겠다. 또 아니면은 저분이 지금 했는데 독일에 아까 98번 그러니까는 17개 인스티튜트가 모여가지고서 딱 테크니컬 파크 같은 걸 만들었다고 했잖아요. 그래서 그렇게 되면은 거기에 관계되어 있는 여러 가지 기술들을 관심이 있으면 한국에 기술 이전도 하고, 아니면은 진짜로 우리 한국에 우리 울산에 일단 계시는 컴퍼니들의 수요가 있다고 한다면은 그쪽에 있는 아까 모였던 그러한 그를 갖다가 우리 여기 브랜치 지점을 만들고 여기 집출을 해서 우리 지역의 기업들하고 코퍼레이션 협력 관계를 맺겠다든지 그러한 데에도 관심이 있고, 또 그렇게 하기 위해서 한국에 왔어요. 그러니까 울산만 온 게 아니라 이 한국 전체를 상대로 해가지고, 그리고 저 사람이 벌써 한국에 방문한 것도 벌써 한 25번, 6번 굉장히 많다고 그래요. 아까 카이텍하고도 코퍼레이션도 하고 협력 관계도 맺고 그렇게 해가지고, 그래서 특별히 우리 울산에 그런 산업체의 수요가 있을 거니까는 당신이 와서 한번 소개를 하면은 관심 있으면은 우리 학부장님을 통해서 한다든지 접촉을 하게 되면 저 사람하고 연결을 시켜가지고서 아켄공대하고 공동연구를 할 수도 있고, 그 다음에 여기 우리 기업에 뭐 필요하다 그러면 독일 스타트업도 뭐 소개를 해준다든지 뭐 그러한 역할도 하고 관심이 있어서 그래서 오게 된 겁니다. 그래서 뭐 혹시 그런데 관심이 있다든지 하게 되면은 아마 박 부장님한테 뭐 접촉 포인트를 한다든지 협력 기회를 제가 오면서도 우리 울산은 대한민국의 산업 수도다 그렇게 해가지고서 상당히 그렇게 하게 되면은 뭐 협력할 기회는 조금 있을 거다 뭐 그렇게 얘기도 했으니까 혹시 관심 있으시면은 박 부장님한테 연락을 하면은 서로 협력할 수 있는 방안이라든지 기회를 찾아보도록 그렇게 하도록 하겠습니다.